tables and rules, but it's kind of like, what do you mean? What is a function? So we have to talk about what a function even is before we can start writing them as equations and stuff. So, we ready? So to do that, we need to talk about what a function isn't versus what it is. And I'm going to save this part right here until after we kind of discover it. So what I want to kind of have you look at is this. So first of all, you have your XY here. And normally that's what your T-chart or your table of values looks like. But I have 3 blanks above each of these. That's because when we get into starting to talk about functions, we no longer say X and Y. We give X and Y different names. So the first thing we're going to say that X and Y, and I'm going to refer to them as something different. X is going to be called your input, which means the Y we're going to call the output. Okay? You can write that in for both. Okay, we may have talked about that. You may have seen it before, yeah? X is also going to be called your domain. And then your Y is referred to as your range. And this next one we may not have room for. But X, when we're graphing things, is always going to be considered your independent variable versus the Y that is the dependent variable. Okay, so kind of try to put that in there. And I'm pretty sure you've heard Miss Larson or Miss Meeks talk about independent versus dependent variables, right? Okay, rate and time and speed and distance and all that. And I want you to think about the word dependent. What does it mean? If you are dependent, you depend on somebody for something. You don't work at Ford Motor Company and have a job and buy groceries. You depend on your parents to have food in the fridge. You are a dependent, right? So we start to think about time and distance. Which one depends on which? Doesn't the distance you go depend on how long you've been going for the time? All right, we're going to talk more about that later, but for right now, I put distant as I was saying it, dependent. So right now, I want you to focus on domain and range and input-output. And you just got to remember it. And you know the easiest way to remember which one's which? Alpha order. X comes before Y, I comes before O, and D comes before R. So, I know it's auto-focusing. So, let's talk about what a function, maybe I need my light. Oh my gosh, I'm going to lose my mind in a second. Okay, yeah, nobody move. Okay. Age and height. So if I were to walk around the room, in this room right now, in my whole class, this table is important to know, and say, hey, I know I don't really have 11-year-olds or 15-year-olds probably yet, but if I were to walk around and say, hey, how tall are you? And then I gather heights from everybody. So if I were to say, hey, this 11-year-old is 43 inches tall, this 12-year-old is 48 inches tall, this 13-year-old is 50, this 13-year-old is also 50, this 15-year-old is 60 inches tall. I could fill in all these heights, right? Okay, that's only 5 feet. So if I were to fill in all these heights, my question to you is, even if I filled all these in, does anything seem weird about this graph? No, not really. So I have a bunch of different kids, and I have more than one kid who's 11, or more than one kid who's 12. No big deal. But guess what? This table does not represent a function. This table is a relation, okay? So a relation is like a correlation. Do you know what correlation means? Correlation means there's a relationship between. So do you think there is a relationship between the amount of hours you study and your grade on a test? Yes. Usually, the more you study, the higher your score. Generally, right? Are there exceptions to that, though? Do you have kids who never study but always score great? Do you have kids who study their butts off but can't score high? So for the most part, a correlation is a relationship between these. Do you think there's a relationship between age and height? Yes. Usually, the older you are, the taller you get until you reach a certain age, and then you're 90, and then you start shrinking, right? Because your bones compress and all that stuff. So we can talk about what this looks like as a graph, but for right now, this is, I want you to put it right next to it, not a function, and we'll talk about why in a minute. You'll see why it's not a function, because now we're going to jump over to this table, and I'm going to tell you that this one is a function. Here's why. I'm going to pick one of these kids, all right? Let's just pick this 13-year-old right here and do a table just for this one kid. So when he was born, you know, when you're born, your height is whatever. Most babies are 19, 21 inches. So this baby was 20 inches when he was born. And now listen, this is important. You only take the height on your birthday. Anybody do the wall things where you have your wall charts? So on their first birthday, they were 29 inches. Babies grow a lot in that first year. They double and triple. So 31. On their third birthday, they were 31. Is there anything weird about that? No. Is that a very likely thing to happen? Yeah. To have two Y values that are the same? What's it mean? Just means you didn't grow, right? Okay. Was it weird to have two Y values over here? No. It just meant what? Two kids are the same height. Was it weird to have two X values over here? No. It just meant there are two 12-year-olds in the class. Would it be weird if I said this? Well, this is 35. On his fifth birthday, he grew an inch. On his sixth birthday, grew a little bit. Didn't grow anymore. 45 inches, 53, 60. So this height is eventually growing. Would it be weird if I did this? I kind of think it would be a little weird. Because if this is the days of their birthdays, when they turned 9, they were this tall. When they turned 12, they were this tall. And when they turned 12 again, they were this tall. So is there something weird about this point right here? Yes. So let me tell you what. Without that point there, this table does represent a function. Why? Because all of the X values and all of the inputs were different. You cannot have any repeating X values if it's going to be a function. So I'm going to have you cross that out, and then I'm going to have you put, yes, it is a function. Okay? The easy way to remember it is because no X values are the same. Okay? That's the easy way. The fancy way to say it is every single input is paired with only one output. Okay? Meaning I'm pairing this one with this, 2 is paired with this, 3 is paired with this. Sometimes each of these, like these can repeat. So the first thing I want you to know is this. Kind of draw like a little line through that. Because if I'm going to ask you, is this a function? I don't care about the range. I don't care about the Y's. All I care about are the X values. If all the X's are different, it's a function. If you have some X values that repeat, it's not a function. It's a relation, but a function is kind of like a real strict type of relation. That's what it is. So no X values can repeat. So the definition of a relation is basically just when there's a correlation or a connection between two things. Okay? You could say, I'm going to use the word correlation because that's a word that you're going to need to know. Between two variables, meaning height and weight, height and age, hours of study, test grade. Do you think there's a correlation between your favorite food and eye color? Does anybody kind of feel like all blue-eyed people's favorite food is pizza, or all brown-eyed people? Like, that's ridiculous. You're looking at me like that's so weird. Yeah, I know, because there's no correlation between those two, right? Okay, so let's do this down here. Let's take a couple of these heights and graph them. So this 11-year-old, by the way, does everybody know what this means right here? When you have a little squiggle in the graph like that? Anybody know? So you know when you graph that every single spacing has to represent the same amount, right? So if I go every two ticks needs to represent another whole year. But then I technically should have started at 0 or 0 here. 1, 2, 3, 4. But all I need is 11 through 15. So am I going to make this really long x-axis when I only need this? So this is called a break in the graph. It means I know my intervals aren't the same, but I don't need 0 through 10. Do you understand? So I only need like 45 through 65. So I know my intervals are not the same, but there's that break in the graph. So watch. This 11-year-old was 43 inches tall. This 12-year-old was 48. This 13-year-old was 50 inches tall. Oops, right here. This 13-year-old was 60 inches tall. Nothing weird about that. They're just two different kids. This 12-year-old was 65. Okay? This is not a function. And in a minute, I'm going to give you a tool to help you recognize this. Because guess what your only assignment today is going to be? To put the word yes or no. I'm going to give you a table, and I'm going to say, is it a function? Yes, it is, or no, it isn't. I'm going to give you a graph, and all you have to do is say, yes, it is, or no, it isn't. But you have to know what information to look at. I'm going to come back to this. Let's look at this. At 0, they were just born, 20 inches, on their day of birth. On their we'll just do every 2. On their second birthday, 31. On their 4th birthday, 35. On their 6th birthday, 38. On their 8th, 40. On their 10th, 53. So the first thing I want to ask you is this. Is that a straight line? No. Guess what? It doesn't need to be a function. This is a function. I'm going to put a big O yes here. I'm going to put a big O no here, because that's all I need you to be able to do today. And we're going to talk about what makes it a function versus what doesn't. How do you know if you look at your x values knowing that they can't repeat? How could you tell a repeating x value from a graph, Ash?
There are 2 points on one line.
Awesome. She said there are 2 points on one line, and it's perfect because there is a test out there called the vertical line test. Have you heard of that? I want you to write those words. The vertical, it's a real thing, line test. And the vertical line test says, take a graph and start drawing a bunch of up and down lines. Like this. And if more than 1 point is on your line, it fails the vertical line test and it's not a function. Here's why. So I want you to put a little extra here. Here's why. Because what's the name of this coordinate right here? It's 12, 48. Right? What's the name of this point on the exact same line? 12, something else. Right? 65. And because 2 of the x values are 12, it is not a function. Do you understand what makes a function a function? Does this pass the vertical line test?
Yes.
Yes, Because every time I draw a vertical line, there's 1 point per line. Yes, it passes the vertical line test. That is a very quick, easy little test to do. All right, so we've done 2 of the 3 ways. Do you know how to tell whether it's a function from a table? Yes, look at the x values. If they're all different, good to go. It's a function. From a graph, draw a vertical line, okay? Now, let's talk about from ordered pairs, which actually might be one of the easiest ways. Actually, I think graph is easy. So, if I give you a bunch of ordered pairs and say, hey guys, is this a function? What are you going to look at? Just the x's, okay? So let's pretend like this little point isn't there. Is this a function? Yeah, 3, 8, 2, good to go. Now, and you might even want to do this. I don't even care about these. I don't even want to look at them. They could all be the same for all I care. The x's can't though. So give me 3 values that you could think of that I could put right there for x to make this data not be a function. Actually, I just skipped this one. So let's just do this one. What are some values that I could put there to make it not represent a function? What's one of them, Ben? 3 would work. Why do I want to use 3? Because there's already a 3. Then what's the other one, Dominic?
8, sorry.
8, yep. 8 can't work. And then Riley? 2. Those are the only 3 that would make it not be a function. Give me a couple that make it do represent. Hey, guess what? Anything except 3, 8, and 2 works. Agreed? Right? Anything except 3, 8, and 2, and you're good to go. It's still a function. All right, so now we got to talk about this. I want you to list the domain and list the range, meaning put D equals R equals. Actually, I lied. In addition to just doing yes and no, yeah, you have to do yes, and then the domain and the range. What's the domain of this function right here? Ignoring this point. Just go ahead and ignore. Pretend like this isn't here. So what's the domain of this function? You just list them. Evan, go ahead.
3, 8, 2.
Okay. And then you know what usually people will do for domains? They'll do it in order. And then what is the range? The range is the y values, and the domain are your x values. This might be one of the easiest lessons we do, right? Are you looking at this going, that's it? Yes, that's it. What's my range? 1, 6, and 5. That's it. Okay? It's not wrong if it's not. Now, be careful, because if I were to say to you 5, 7, 3, 7, 8, 7, and 5, 6. What's the domain? What's the range? Is it a function, yes or no? No. Why is it not a function? Because there's 2 repeating x values. Because there's each input is paired with more than one. Each output is paired with more than one input. What's the domain? 5, 3, and 8. Now hold on a second. There's 2 5s. So if I say 5, but I only really need to write one of them, 3, 8, and my range is 7 and 6, because I don't need to write the repeating. Why do you not want to use your list of domain and range to tell whether it's a function or not? Why do you want to use your ordered pairs? Because what? Yes, because if you have a repeating y or x value up here, but you don't write it in your domain, then you're going to think it's a function, and it's really not. Okay, all right. We already kind of did this one. I already taught you the vertical line test. Tell me yes or no.
No. Yes.
Yeah?
Yes. Yes.
About the next one? Yes. How about the next one? No. I think one of the ones I give you on the test is like a circle or something. Yes or no?
No.
No. Why not? Because it touches it in 2 places. So this would be a no. Okay? All right. The last thing I'm going to show you is something kooky called a mapping diagram. And it looks like this. Do you think that I really need to kind of explain it? It's kind of like, can you tell based on the arrows whether it's a yes or no? Think about it for a minute. Basically, you can make ordered pairs based on these. So a 6 is paired with a 3. A 12 is paired with a 4. Another 12 is paired with a 1. Can I stop right now? I have enough information because right now there's more than one x value. Is this a yes or no? Nope. This 3 is paired with this 8. This 6 goes with the 7. The 9 with the 4. And the 12 with the 3. Are we good? Yes. Okay. Ooh, this one's dangerous. It's very dangerous. Because if you think all you have to do is look and see if there's repeating numbers like you do in tables, you are in trouble. Because this is not a function. But I know somebody says, well, I see 2, 4, 6, and 8. Yeah, it is. There's nothing that repeats. What about these arrows? How many arrows are coming out of that 2? 2. Ah. So is this input 2 paired with 10? No. Yeah. And what else is it paired with? Ah. So I got 2 arrows coming out of the same number. Not a function. So you could put no or not a function. Doesn't matter. So this is the only one that was? Yeah. So be careful because sometimes they'll put 2 12s. Sometimes they'll only put 1, but put 2 arrows coming out of it. All right? So that is